Okay, so now we are going to move on to what is truly our last unit. I know on the last one I said it was the last unit, but then we had more time. So now we're truly in the last unit, and we're going to look at circles. Nothing but circles. We had one day earlier this year where we talked about the area and circumference of circles and all that jazz. But now we're going to really dig into what happens if I have a circle and then I'll take a line and go through it. Or I have a line that touches my circle or stuff like that. So let's jump into it. First thing we want to differentiate between is the interior versus the exterior of the circle. So the interior of the circle is everything that's inside the circle. The interior of a circle is the set of all points inside that circle. Think of it like you enter a house. The interior of the house is everything inside the house. The exterior of the circle is all points outside that circle. So if you exit your house, you go out of your house, everything that's on the exterior of your house is outside. So let's look at some lines and segments that intersect a circle. The first one we have is a chord. It's a segment whose endpoints lie on the circle. So if we look at our picture here, AB is considered a chord. Segment AB is a chord. Those endpoints are on the edges of the circle. So AB is a chord. A secant is a line that intersects the circle at 2 points. So line L, it goes in the circle and it goes out of the circle. It enters and then it exits. That's a secant. Then we have a tangent. A tangent is a line in the same plane as the circle, but it intersects it at only 1 point. And like it gets, like here's our circle, it's going to get really, really close to it, touch it, and then take off. It's kind of like when you were little and your siblings were messing with you. I'm not touching you. I'm not touching you. I'm not touching you. Oh, I touched you. I'm not touching you anymore, though. They get close, they touch it, and they run away. That's a tangent. So line M is tangent. And then the point where the tangent and a circle actually touch. So that point, like if this is the edge of your circle, that point where they touch, that is called the point of tangency. So again, in our picture, point C is our point of tangency. Okay, so let's look at an example. And some of these are words that we just went over. Some of them are ones that we may have to remember from, I'll say it was Unit 3, when we did area. And we first started talking about circles. So a chord. We said a chord is a segment where the endpoints lie on the edges of the circle. Well, in this picture, there's actually 2 chords. BC is a chord. The endpoints of B and C lie on the edges of that circle. So segment BC. Now, EF, you could also argue is a chord as long as you say segment EF. Because that means it starts and stops on the edge of that circle. If you say segment EF, you're good. If you just told me EF, I'm going to say, well, EF could be a line. It could be a segment. What are you talking about, EF? Segment EF, good. EF, not good. Now, line EF would be considered a secant. It goes into the circle at E, and then goes out of the circle at F. That's a secant. And then for a tangent, we want the line that touches the circle at only one point. That would be line L. You can't say CL. L is not a point. L is the line itself. So L. Now let's look for the diameter. The diameter is the one that goes all the way across the circle at the longest point. So BC is the diameter. And then the radii. Remember, our radius goes only halfway across the circle. So we actually have two. We have AC and we have AB. Those are our radii. Okay, so let's look at part B. Part B, we get another picture. Identify each line or segment that intersects circle D. The chords. Well, again, they start and stop on the edge of the circle. So we have AB. Segment AB. And we have segment CE. Those are chords. The secant goes into the circle and out of the circle. So the secant will be line AB. Make sure to put your line symbol on top. The tangent, we only touch the circle at one point. So I look for the line that touches it at only one point. That is line EF. We only touch at one point. Now the diameter, which one goes all the way across at like the widest part of the circle? CE, segment CE is your diameter. The radii would be DC and DE. Okay, there's example one. We're just naming the segments. We'll get to relationships on the back here, but right now we're just naming the segments. Example two. Find the length of the radius, identify the point of tangency, and write an equation of the tangent line at this point. Okay, so for circle A, circle A, our point's in the middle here. We want to see how big is the radius. So 1, 2, 3, 4. That radius is 4. So the radius of circle A is equal to 4. And then we're just going to use units. We don't know if it's inches, centimeters, feet, football fields, whatever. So we're just going to say units. Now they ask us to find the radius of circle B. Start in the middle at B and then go out. 1, 2. It's going to be 2 units. Now the point of tangency. Remember, that's the single point where we have our circle and the line touches the circle and then goes off forever. So the point of tangency would be whatever point is on that line where it touches both circles. So right here. How could we name that coordinate? Well, that's 1, 2, that's 3. Our x value is 3. Y value is 0. That's our point of tangency, 3, 0. And then we have the equation of the tangent line. So for the equation of the tangent line, I need to write the equation, the tangent line. Whoa, it's a little big. 1 second. Come back. There we go. Tangent line. Our tangent line is this line right here. I need to write the equation of that line. Well, for one, what kind of line is it? It's a vertical line. And so a vertical line has what kind of slope? Undefined. So this is a line that's going to be x equals something. That's going to be our equation. X equals, well, what is the x at that point? X is 3. So x equals 3 is the equation of your tangent line. Okay, so now let's flip over to the back of the notes and keep going. We're going to have a similar example. They want us to find the length of each radius, identify the point of tangency, and write the equation of the tangent line. So first they ask us about circle M. That's the baby circle. So we go 1 over. So our radius is 1 unit. Then they ask for the radius of circle N. So we go to circle N, 1, 2. It's going to be 2 units. Okay, the point of tangency. So where does a line go through, touch a circle, and then go on forever? Well, the only line I see other than my axes is that line right there. So I need to know the point where it touches the circle. That point would be right there. Then you're like, but it touches it at more than one point. It looks like it. In the picture, yes, you're right, it does. But if we were to just really zoom in on that picture, you would see that it only touches it at that point. It gets really close, but it's not touching it. It's like your sibling. If this is your back, I'm not touching you. I'm not touching you. If you look, they're really close, but they're not touching you. Oh, they're touching you, and then they back off. That's kind of what tangent does. So what point is that? What point do they say, oh, I'm touching you? 1, looks like -2, 0. And then we want to write the equation of that line. Now, just like before, it's a vertical line. So we're going to have x equals, and then x is -2. So x equals -2. There we go. So far, we haven't done too much math other than writing the equation of a line. Let's get to the math. Math is fun. Math is F-U-N. Fun, fun, fun. If two segments are tangent to the circle from the same point. So we have point A right here. They start at the same point and they're both tangent to the circle. Then the segments are congruent. So what this is saying is segment AB is congruent to segment AC. That's all that theorem is saying. If they start at the same point and then they split off and they're both tangent to the circle, those two are congruent. They're equal. So let's look at this example 3. DE and DF are tangent to circle C. Find DF. They're both starting at D. They're both tangent. The problem tells us that. So that means these two have to be equal. So set them equal. 3y equals 5y minus 28. We're going to move the 5y over. Negative 2y equals negative 28. Divide by negative 2. And we get y equals 14. Are we done? No, they ask us to find DF. DF is this line right here. So I have to take that 14 and plug in. 3 times 14 gives us, 42. Now we're done. Okay, let's look at the next one. A central angle is an angle whose vertex is the center of a circle. An arc is an unbroken part of a circle consisting of 2 points called the endpoints. And all the points on the circle between them. So an arc is basically just a part of the edge of the circle. That's it. But we have several different kinds of arcs. First one we have is called a minor arc. And on a minor arc, the measure of a minor arc is the measure of its central angle. Okay, so there's 2 things to know about a minor arc. Thing number 1, a minor arc is going to be less than 180 degrees. That's thing number 1. Thing number 2, it's going to be named with 2 points. So it's less than 180 degrees and it's named with 2 points. So like here in this picture, the minor arc is AC, arc AC. The opposite of minor is major. A major arc is an arc whose points are on or in the exterior of the central angle. So the measure of a major arc is equal to 360 degrees minus its central angle. So 2 things to know about a major arc. 1, greater than 180. And 2. It's named with 3 points. So a minor arc is the small one. It's kind of in between your angles here. A major arc is the one that goes all the way around. It's major. It's a big deal. Major things are big deals. Minor things are little bitty deals. If you're having a minor breakdown, that means you're going to be okay. You may just be upset for a few minutes. If it's a major breakdown, the world is ending. Yeah, it's bad. Major, big. Minor, small. That's how you can remember those. If the endpoints of an arc lie on the diameter, then the arc is called a semicircle. It's half of a circle. So, semicircle. Two extra things to know about it. It is half of a circle. I can't spell evidently. And it's also named by 3 letters or 3 points. Okay, so the measure of a semicircle is always 180 degrees. So the measure of arc EFG is 180. Now, EG right here, this is the diameter. Okay, so just to emphasize again, we talked about it up here. We wrote it in green, but just emphasize again. Minor arcs are named by 2 points. Major arcs and semicircles need 3 points. Remember, minor, it's small. It's not a big deal. Major arcs and then semicircles, those are big deals. The world is going to end. Okay. So now they want us to find the different arcs. Now here's what we're going to do. We actually know enough to fill this whole circle in without seeing what they're asking for. So we're going to do that, and then we'll go back and see what they actually ask us for. All of our same geometry rules apply. With that being said, they still apply. So if you have vertical angles, use them. Like here, this little piece right here that I'm highlighting in yellow, AB, that has to be the same as DE right here. So this one, this piece right there is 18 degrees. This box, this red box, means it's a right angle. That's 90 degrees. Now we just need to know these other 2 pieces. There's a couple of different ways you can look at it. One way is to say, well, you know what? I know I put my smart big boy cap on. I know that A to D is a half circle. And half circles are 180 degrees. So I'm going to add 90 plus 18. That's going to give me 108. And then I'm going to subtract that from 180 because a half circle is 180 degrees. That gets me 72. So this angle right here is 72 degrees. Now, I also know that if I go the other way, from A to D, that's also 180. Part of it's 18. So if I do 180 minus 18, it gets 162. This piece is 162 degrees. I've now figured out all the small angles in the circle. So let's see what they actually ask us for. First, they ask us about arc CE. So from C all the way to E. I add up whatever pieces I come across, I'm going to add them up. So 90 plus 18. 90 plus 18 is going to give us 108 degrees. There we go. We're done with that one. And then we have AE. So from A, it's just from, here's something to think about. AE, what direction do I go? Do I go the long way around or the short way around? Well, how many letters does it have? It has 2 letters. It's a small. It's a minor arc. So I go the short way around. AE. That's 162 degrees. So remember, 2 letters, small arc. 3 letters, it's either a major arc or a semicircle. Okay, so that's our lesson for today. Stay tuned for the guided practice.